We are now going to talk about a complete graph. So a graph where every vertex is directly connected to every other vertex. Each vertex has an edge connecting it to every other vertex of the graph. For a complete graph, we can calculate how many edges there are by using the following formula. So this is the formula that will tell us the amount of edges for any complete graph. And remember, a complete graph is when every vertex is directly connected to every other vertex. So in this formula right here, we have k of n, and I'll actually change up the colors here. If I have k of n, and what that is telling me is the number of edges. And what else do we have here? We have n, which is telling me the number of vertices. So this n here is the number of vertices in the network. So this rule can help us determine if a graph is complete. So let's look here. Is this a complete graph? Well, it is, because every vertex is connected to every other vertex. So if we look here, this k of 3 is going to tell me the amount of edges that are going to occur. And then n, so n here is the amount of vertex I have. So I have 3 vertices. So I've gone 3, then 3 minus 1. So this is 3 times 2 is 6, divided by 2 is 3 edges. So this right here is 3 edges right there. And this kind of confirms to us that it worked, because if I look at my graph now, 1, 2, 3, I in fact do have 3 edges. So if we come over here and do it again, so this is telling me the amount of edges I'm going to have. I put in the amount of vertices I have. So here I've got 1, 2, 3, 4, 5. 5 minus 1 is 4. 5 4s are 20. 20 divided by 2 is 10. So that means I have 10 edges. So now we can double check that. We have 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 10 edges right there. So this indeed is a complete graph. Perfect. The way this comes up most of the time, and hopefully this is a bit familiar to you from our study of matrices, is when you've got like a round robin competition and everyone has to play against everyone else. So a way that this can be formulated in a question would be something like, if you have 5 people in a competition and everyone has to compete against each other, how many matches need to take place? And what in actuality they're asking for there is the amount of edges. But of course, they might not use the word edges. They might frame this in terms of like a competition. Or, as we'll see later, maybe, if these are 5 people and everyone needs to shake each other's hands, how many handshakes will there be altogether? So they're always going to try to contextualize it in different ways to try to trip you up. But this is what you're dealing with when you're trying to find the different amount of edges for a complete graph. All right, we'll now go through some examples.